So I made a little 3D drawing in Tinkercad here. Let's get rid of this, close that down. All right, so let's see. We've got a cube. We have the orange rods are the electric field lines. I didn't put arrows on them, but let's presume they point upward, right? Down being the blue workspace here. Right, so all the electric field lines are pointing upward, and I put the, oops, didn't want to do that. I put the green area vectors that point outward perpendicular to each surface of the cube, right? So now you can see that for the top face, the area vector points in the same direction as the electric field. For the bottom face, it points in the opposite direction of the electric field. Remember, the electric field is here. I didn't put the arrows on, but they're all pointing upward. But for the other four faces, the area vector for those green area vectors for the side faces point at 90 degrees relative to the electric field. You see how the electric field is, let me find a good orientation here. The electric field is pointing up, and this guy is pointing to the right, so that's 90 degrees. This one's pointing to the left, this is pointing up, that's 90 degrees. If I rotate around this one to this face, that's pointing left, that one's up. That one's pointing that way, that one's pointing up, those are all 90 degrees. The top face is parallel, so that's 0 degrees. The bottom face is anti-parallel. The electric fields are up, the arrow for the vector, the area vector is pointing down for that face, right? So that's 180 degrees. And that's why cosine of 90 degrees is 0. So these side faces do not contribute at all to the flux because it's EA cosine theta. The top one, EA cosine theta, is cosine of 0, so that's +1. Bottom face is EA cosine of 180 degrees, right? So that's -1. So the +1 and the -1 cancel. The four side faces contribute 0. So the net flux through the entire cube is 0.